This is the list of data that you have on the top of page 20. I just had to write it in 2 lines because I couldn't fit it up here. I just want to make sure I had it to point at it. So there's some numbers there. Maybe they are ages. Maybe a bunch of people at a family reunion. That would make sense, right? If we have ages between, what's the smallest one? 6? What's the biggest one? 70? Yeah, that could be people at a family reunion between ages 6 and 70. A bunch of ages. So that's just a long list of numbers. If I asked you some questions about it, like are there more younger people or older people? Is it evenly spread out from young people to old people? Is there any group that there's more of or less? I could ask you all these questions, and it'd be a little hard to answer the way it's just written there in the list. Well, let me start counting. I mean, the first thing you might want to do if I ask those questions might be to rearrange them. That's what a stem plot does. A stem plot is the first thing we're going to do. It rearranges the data, it puts them in order nicely, and even tells you about the distribution. Maybe it's distributed normally. We'll see that. So we're going to make a stem plot. There's 2 vertical lines on your paper. The second one's actually going to be our stem plot. The first one is what I call my scratch paper to get started for my stem plot. Your stem plot takes numbers and breaks them into separate digits. In this case, these numbers all have 1 digit or 2 digits. They have to all be the same. Like they have to either all be 2 or all be 1 for us to compare them. But I'd argue that we could write, for example, 9 as a 2-digit number. If we wanted to, what would it look like? 0, 9, right? So we could make this, I mean, we don't usually write it that way, but if we had to make it a 2-digit number, we could. Kind of like if you're doing like the pennies part of when you buy something, right? Put 0.09, right? Same idea. So then we could write them all as 2-digit numbers. If they were, can you pull that door shut, please? Yeah. Thank you. If they were all, say, if any of them were 3-digit numbers, we'd have to write them all as 3-digit numbers. So that would be 009 or something like that. So they'd have to all match. And then we say, okay, we separate the last digit. There's 1 digit at the end, which means they all have 1 digit at the beginning. Just looking at the first digits, what are my first digits? What's the lowest first digit and the highest first digit in this list? What's the second digit, the first digit? 0. And, sorry?
7.
7? Yeah, because I've got things from 1-digit numbers up to, I think 70 is my highest. So the first digits are going to come over here. They call it a stem plot. This side they call the stems, and this side they call the leaves. Some people call it a stem and leaf plot. So my stems are the first digits. 0, 1, 2, 3, 4, 5, 6, 7. It doesn't matter if I don't have one of each of these. I have to have everything from the smallest to the biggest represented here. So if I didn't have, say, anybody in the 50s, I think I do, but if I didn't have anyone in the 50s, I still would have to list the 5 here, because these have to be evenly spaced. Everyone all right where those ones came from? So the stems are the first digits in this example. And so now I'm going to easily organize these into groups. I'm going to put them in the right places. So this 9 we said was a 0, 9. So it goes with the 0, so I'm going to put the 9 here. It goes with this guy. The 15 is a 1 and a 5, so the 1 here and the 5 goes here. The next one's a 25, so that goes with the 2 and then the 5. Everyone all right? How I know where to put these? Yes.
The 6 need to go before the 9.
I'm not there yet, but it will, yes. The answer is yes, but I'm not there yet. 47. So right now I'm just going across my list, putting the leaves on my plot here, next to the correct stems.
Wait, why did you skip the 3? Oh.
I'm just putting each of these numbers. That's actually why I listed them, to make sure I didn't forget any of them. So I've now put those numbers up there. So it's not that I skipped the 3, I'm just putting my list onto this chart. I'm glad you asked though. Other questions on how I'm putting this there? Yes.
How did 16 on there? Because are you on the
Aha, he wants to know what to do with the 16. That's exactly where we are. Wait a minute, we already have a 5 there. You might have a long list of numbers on this 1 digit. So he wants to know how to put the 16. There's already a 5 here. We just put the 6 right next to it.
Whoa.
I know, well, no commas, just right next to it, kind of evenly spaced, kind of think of these as columns. So this tells me, if I hadn't looked up here, this tells me there's a 15 and a 16 in my list. Same thing with the 6, right? The 6 is a 0, 6, so I would just put it over here. You want to make sure you evenly space these when you put them in there. You don't want to squish some of them together and spread some out. I'll talk about why in a few minutes. So there's the 6. The 28 would go here. I want to make sure I don't lose my place because I keep stopping to talk. Other questions on how I'm putting those on there? Make sure you ask me a question now, 'cause I'm about to have you finish it. Everyone knows how to put the rest of those numbers on here.
Well, what about the 32? Would you put it in the first column?
Yes. So everyone hear her question? The 32 is the first one that goes with the 3. So you always start on the left and just keep filling them in as you go. So the 32 will go there. They only just keep moving over columns if you have more of them. So do me a favor, see if you can put the rest of them on there. You're done already? That's what happens. I start talking and people are like, "I've already done, Jill." Some people were listening though and not writing. For those of you who are, we're not done yet, see if you can fit all those numbers on there. While you're doing that, I'm going to put them on here real quick and we'll see if we agree. Hopefully I copied the list down right. We'll find out if my list doesn't agree with yours here. Does that agree with yours? You could have made a mistake, so if yours is different than mine, just let me know. So what we got? So this kind of tells me a lot of information already. This tells me right now I've got 5 numbers that are, 5 people who are under the age of 10, if their ages, right? I've got 2 people that are in their teens, 2 teenagers, 4 people in their 20s. I have just as many people in my 40s as I do that are under 10, because I have 5 people in this list and 5 people in this list, which is why you want to keep them evenly spaced so you can tell when they're the same length. So here's the bad news. That's not a stem plot. It's almost a stem plot, which is what Christiana's question was about. To be a stem plot, it's almost like this, except your leaves have to be in order. So that's why I gave you 2 lines here. This is my scratch paper to get started. Now I'm just going to come over here, recopy my stems, and then put each row in order from smallest to biggest. If you can do that all in one step, good for you. But it's hard to find the smallest one, and you have to move things over if you miss it. So for me, it's actually easier to make one here and then reorder it so you get to my answer. So I'm going to put these in order from smallest to biggest. 6, 6, 6, 7, 9. 1, 5, 8, 8. Putting 2 or 3 numbers in order is a lot easier than putting 22 numbers in order. 0, 1. And these were all in order already. So this guy, right here, is my stem plot. It has the stems, it has the leaves, everything's in order. Questions on that? Here's what we love about stem plots. Number 1, it takes a long list of data and puts it into a nice compact space. If I give you one of these, big hint, on the next test, if I give you a stem plot and say what numbers are listed in this table, could you tell me? If you didn't know what they looked like up here, could you read it off of here?
Yeah.
Yeah, right? This one represents a 40 and a 41 and a 45. So you could take them off. So it's all the numbers in a nice compact space. If I asked you for the smallest number, could you find it? Sure, it's right there at the top, right? The biggest number you could find it. And you don't have to search and say, oh wait, I missed one. There's another one bigger or smaller. the longer the list, the harder it is to find things like that in there. Could you find the one right in the middle? Right in the middle? You had to? How would we find one right in the middle?
Counting.
Yeah?
Could you like add like the smallest number and biggest number and divide by 2? Could you like an average?
That's kind of an average, but if I actually wanted the exact number that was in the middle of all these, if I had, so that's a good estimate though, I like your idea. But there might be a number like right in the middle, where half people are younger and half people are older. Yes,
Maybe if you go up to the middle column, like go to the 4 and then go to the middle number in the 4.
okay, so
45.
like the 45? So I like her thinking, is that the middle? How many people are older than 45? 1, 2, 3, 4, 5, 6. How many are younger than 45? A lot more than 6. I like thinking out loud's good though. Yes?
So you just count from the top and the bottom, then you, in the middle.
We could count from the top and bottom until they meet. We could count how many there are and just take half of it. Turns out there's 22 if you count them. So if I counted from the top and the bottom, I'd go 11 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 right there from the top. If I did 11 from the bottom, I'd be, so this is 11 from the top. This is 11 from the bottom. So I went backwards, right?
So what did you say?
What'd you say? I didn't hear you. Never mind. She was thinking but didn't like it. Say it again?
Between 28 and 32.
It's between 28 and 32, which I think is what you said, she just didn't trust herself. We don't have one number right in the middle. But do we agree that half the people are 28 and younger, and half the people are 32 and older? So halfway between those would be 30? So 30 would be the number that half the people are younger and half the people are older. We're gonna learn that later, it's called the median. It's actually a chapter 3 terminology. But because they're in order here, we can actually even find that. Where if I had just given you this list and said, hey, figure out what number is exactly the one that half the people are older and half are younger, good luck finding it looking at this list. I don't know if I would have come up with 30 looking at it. So this organizes it a lot.